Hello and welcome. Today we will discuss continue to discuss what is the function of each component in a mobile charger. Earlier we have discussed about the capacitor and we calculate how to select the value of a capacitor. Now we will go to the transformer. What is the purpose of the transformer and how we can get the desired output? By selecting the value of the transformer. Consider the primary of the transformer. The primary is connected to the positive side and to the negative side through a switch. The switch is the transistor. Current, when the switch is on, the current will start to increase from 0 to a value. The rise, that is the rate of change. That means, let's say this is a 10 microsecond. And in 10 microsecond, if we reach a 3 ampere current, then this primary inductor should have a value. This we can get from the equation di by dt. Di by dt is equal to V by L. What it means? It means that di by dt means the change in current. This is the rate of change of current. That means in a particular time what will be the current, what the current value will be reached. If the voltage, let's say if we apply 300 volt, let's say the capacitor, usually capacitor voltage is 300 volt. If we rectify from the main supply around 300, 320 or 300, let's say the voltage is 300 and we have put a 1 millihenry capacitor. 1 millihenry inductor is the primary inductor, 1 millihenry. Then this will go to the upper side in 300 into 10 raised to 3. That means in 1 second, the current would reach a value of 3 lakhs ampere in 1 second. Usually we are not on the transistor for this much time. We are on the transistor for a little time. Let's say this is the inductor with 1 millihenry inductance and we connect a transistor. This is the transistor and we are applying a signal, on-off signal to the base of the transistor. This is 300 volt and it is connected to here. If we apply a frequency, on-off switch, the on-off frequency is, let's say the frequency is 50 kilohertz. The time will be, repetition time will be 1 by 50 kilohertz. 50 kilohertz means 10 raised to 3. And it will be, if we calculate it, it will be around 20 microsecond. The repetition will be, the signal will be repeated at every 20 microseconds. And if we on the transistor for half the time and half the time it is off, that is, if the D means the time period, that is it is on, if half means 20 microsecond into half, 0.5, T on, time will be 10 microsecond. The transistor will on for 10 microseconds. Then what will be the current? By that time, what will be the current? We have taken this V by L is di by dt is equal to 300 divided by 1 millihenry is given by 300 into 10 raised to minus 3. If it is for 1 second. If we on the transistor just for 10 microseconds, 10 into 10 raised to minus 6. This will be with 3 ampere. That means in 10 microseconds, the current will reach, if this is the plot, and if we on the transistor, if we just on the transistor for 10 microseconds, the current will be, if the inductor is 1 millihenry, the current will, this is 10 microseconds. in 10 microsecond the current will reach 3 ampere. 3 ampere of current will be reached in 1 second, and each electron the current will possess 300 volt of energy. 300 volt. If this is the peak value, what will be the average value? This is the, if it is the 3 ampere for the full time, the current will be 3 ampere, but it is not for the full time, so we can calculate the average current will be half of this portion is not there, so half of this, half into this is the 3 ampere, 3 into 10 microsecond, 10 to 10 raised to minus 6. It will give, in 10 microseconds there will be 15 microampere of current. Total energy in the core of the transformer is 50 microampere. In each electron possesses 300 volts, so the total will be, that means the total energy in the core by the on time. If we select a 1 millihenry, if we select a 1 millihenry capacitor, the current would reach to 3 ampere. The average current will be 15 microampere. If 15 microampere current with 300 volt, the total energy in 10 microseconds, stored in the core of the transformer will be 4.5 milliwatt of energy will be stored in the core of the transformer. And 4.5 milliwatt is for 10 microseconds. Then the frequency is 10 microsecond, and it is, the frequency is 50 kilohertz. And this is 4.5 into 10 raised to minus 3. This is milliwatt into 50 kilohertz, 10 raised to 3. 225 watt of energy will be stored in the capacitor per second. That is not continuously. If in the one cycle, when it is on, 4.5 will be stored in the transformer, and it will be released. Like that, 225 watt of energy will be stored in 1 second. Now, how we can calculate the secondary winding? We know the equation that V1 by V0 is equal to N1 by N2. That means we know that this is the primary and this is the secondary, and if we want this is 300 volts, and if we want 150 volt here, is the primary turns and the secondary turns is 50. That means 0.5. N1 to N2 to N1. The ratio of N2 to N1 will be 0.5. But even though the turns ratio is half, but the inductor value is, from looking at the secondary side, the inductance L secondary will be L primary into N square would be the secondary value, inductance value. That means if the primary inductance is 1 millihenry and the secondary is half means 1 by 2, then we have to square it. Then we will get 1 by 4 of the primary is 100 and the coil in the secondary is 50. Then means half the coil. But the inductance seen by the secondary will be 1/4 of the primary. And when the transistor is off, the rate of change at which the secondary current is decreasing is not same as the rate of change of the primary current. Why? Because if we say that when the transistor is on and after 10 microseconds, there will be 3 ampere of current, and each electron possesses 300 volt. 3 ampere of current possesses 300 volt means at that moment the energy in the core of the transformer is 900 watt. That means 3 ampere of current possesses 300 volts, therefore 900 watt of power is there. And if take a time, half of that, if say a 5 microsecond time, then the current will not be reached there. The current position will be around 1.5 ampere, and at that position the energy will be 1.5 of current with 300 volt means 450 watt of energy will be stored in the core of the transformer. But if we take when the transistor is off, the energy in the core of the transformer is 900 watt. So to maintain that, the voltage is 150. So more electron has to carry this energy. Here only 3 ampere of current is carrying 300 volts. So the total energy become 900 watt. Here the voltage is only 150. So more electron has to carry the energy. So 6 ampere of current is carrying 150 watt, a less amount of energy. So the total become 900 watt. At the instant when the switch is off, at the instant when the transistor is off, this for maintaining this amount of energy, the property of the magnetic flux is that it wants to remain in the same energy. When the transistor is off, the energy is 900 watts and it wants to remain there. It is like the property of inertia. It wants like to stay in 900 watt. In order to stay in 900 watt, and the output voltage is, we are taking 150 volts. In order to maintain that energy, 6 ampere of current, each electron possesses only 150 volt here. So more electron has to be gone. More electron has to carry the same 150 volt of energy, then only it becomes 900 watt. And if we take a middle point like this, after 5 microseconds, what will be the energy? After 5 microseconds, half the time, the energy, the current will be 3 ampere. If this change is 1.5 in 5 microseconds, the change is 1.5 ampere in 5 microseconds. That means the change is around 0.3. Changed from 6 ampere to 3 ampere. That means the change is 3 ampere in 5 microseconds. That means the change is not the same. This is 6. That means more change. The rate of change is more. The rate of change of current is more. Here it is 3. 1 for the same time 5 microseconds, the change of current is from 3 to 1.5 means 1.5 has been changed in 5 microseconds. That means the rate of change of is only 0.3. Here the rate of change is 0.6. That means more current has changed. Current is changing rapidly. V0 become half. How is it? We know that the turns ratio become half of the primary. Turns ratio is half. But we can check here that after 5 microseconds, for the period of 5 microseconds, the energy is same. It is changed from 900 watt to 450 watt after 5 microsecond here. The change will be 450 watt. And here also after 5 microsecond, the energy is changed from 900 to 450 watt. That means 450 watt. The change in energy is same, but the number of winding is half. Change in energy means the flux is changing in the same way, in the same time. That means the rate of change of flux is same, but the number of coil is half. So what happens is that this is the primary and this is the secondary. This has 100 turns and this has 10 turns and this has 5 turns, let's say. And when the transistor is on, the rate of change is same in both cases. That means if we take here, we see that after 5 microseconds, the energy, voltage is equal to N into d phi by dt. d phi by dt means the change in flux, change in energy. The change in energy is same for both cases, but the flux is half. But the number of coils is half is there. So the voltage at the output will be half. It is same. So the output voltage will be half, but it is compensated by more current. More current carrying electrons. More electrons are carrying this much of current, and thus maintain the same energy. So the energy is the same, but the power is the same, but the voltage is half. Voltage become half, and the electrons carry the same power with more number of electrons. That is what is happening in this transformer. By selecting the frequency and the value of the primary inductor, we can select the correct value of the output power.